Hello class. Today we are looking at the key features of a graph. This will include minimums, maximums, what happens at both ends of our graphs, and anything that might be different. So, the essential question is, what are the key features of a graph? Your learning intention is, I'm learning to find key features of a graph of functions and to identify their end behavior. You've got two warm-up questions, so please pause the video. You're going to graph the equation, and you're going to evaluate a function. Pause the video and see if you can do those on your own. I do hope you tried. So if we're looking at the equation, this is in standard form. I've got 3x plus 6y equals 18. I know that 3 divides evenly into 18 and 6 divides evenly into 18. So I can find the x and y intercepts and use those 2 points to be able to graph. So let's start off with x is equal to 0. So it's 3 times 0 plus 6y is equal to 18. 6y is equal to 18. Y is equal to 6. So the first point is 0, 6. For the second point, I'm going to have y is equal to 0. So 3x plus 6 times 0 is equal to 18. 3x is equal to 18. X is equal to 6. So my other point is 6, 0. I'm ready to graph. So 0, 6, 0, 6 is right here. 6, 0 is over here. I'm going to draw my graph in between. Oh, this should be 3, not 6. So 18 divided by 6 is 3. I knew that did not look right. And that is my graph. Okay, looking at the next problem, if I evaluate the function h with x, I get 3x squared minus 1. But I want to evaluate h with negative 3. Remember, this means that x is equal to negative 3. I'm going to substitute in 3 times negative 3 squared minus 1. Substitute in. Negative 3 times negative 3 is 9. So I've got 3 times 9 minus 1. 3 times 9 is 27. 27 minus 1. So when I take h and I substitute negative 3 in for x, my answer is 26. Okay, take a minute and look at both of those questions. If you have any questions, back it up and listen to it again or talk to me. Okay, what is the minimum value of a function? The minimum value of a function is the y-coordinate of the lowest point of the graph of a function. The y-coordinate of the lowest point on the graph of a function. Okay, so if the minimum is the lowest point, the maximum has to be the highest point. So it's the y-coordinate of the highest point on the graph of a function. The y-coordinate of the highest point on the graph of a function. So, no big surprises with those two definitions. So how do we find the domain, range, maximum and minimum of functions? Remember, we're going to use that interval notation. So the domain is your inputs. And those would be your x values. So if I'm looking at x, I start at -5. -5 it's a filled in circle, less than or equal to x. I go up to +5. It's also a filled in circle, less than or equal to 5. And that's my domain. My range is the outputs, which is your f of x. So for my range, it's your y values. I start at -7.5, filled in circle, so it's less than or equal to f of x, which is less than or equal to 7.5 is my endpoint. I forgot to underline this with the right color. Okay, domain and range. This is interval notation. What is my maximum? Remember, it is the y-coordinate. My y-coordinate is 7.5. What is my minimum? That's the lowest point on the graph. The y-coordinate of the lowest point is -7.5. So your maximum is your highest point, your minimum is your lowest point, but you're only looking at the y value, or the f of x value, the output. Okay, for the other one, what do we notice that is different? If you say it's a line that goes on forever, you are correct. So let's look at what this does to our domain. It goes to -infinity is less than x. Remember, it can't be equal to x because we don't know what the largest infinity is, or the smallest. So it goes to +infinity on the other side. This way it's going to -infinity, this way it's going to positive. What about our range? Well, once again, we're going to -infinity and +infinity. And this time our function is g of x. Okay, what about minimums and maximums? Well, there aren't any because it doesn't stop. So functions do not necessarily have a minimum or maximum value. Okay, so that's how you find range, minimum, domain, range, minimum, and maximum. Okay, looking at the chart, we've got a function and we've got characteristics. Which characteristic goes with which function? So I'm going to look at A. My slope is negative. That means it is decreasing. Okay, if I put 0 over here for x, or for f of x, I'll have 0 is equal to negative 2x plus 4. So to solve, I'll subtract 4 from both sides. Negative 4 is equal to negative 2x. Divide by negative 2, 2 is equal to x. So 2 is a 0, and it is decreasing. For B, positive slope, so it is increasing. If I set it up, 0 is equal to x minus 2. Then I'll add 2 to both sides, and 2 is equal to x. So this 0 is 2. So this is number 4. Okay, let's look at C. So I've got 0 is equal to 3x plus 5. So I would subtract 5 and divide by 3. Negative 5 over 3 is equal to x. So that one is not negative 4 as a 0. So we're looking at these two. Y-intercept of 5. Well, this time if I put in 0 for x, I do get 5. And I start, if I'm looking, this is positive, so I'll start at negative infinity and go to positive infinity. So if I'm looking at 3x, this is a positive slope. So as f of x goes to positive infinity, my x also goes to positive infinity, and this would be number 1. Okay, for D, it's decreasing. I've got 0 is equal to negative 3x minus 12. I'm looking to see where my 0 is. Add 12 to both sides and then divide it by 3. That gives me negative 4, and that's what is equal to x. So this is actually 5. And so E has got to be number 2. Y-intercept of 5, so if I put 0 in, I've got 5. So this is a negative slope. It starts at the bottom and goes up. So as this goes to positive infinity, your x value also goes to positive infinity. Minimums, maximums, and zeros. Remember, this is a graph. This goes on forever and ever, both directions. Do I have a minimum? Nope. The minimum is negative infinity. We don't know what that is. Do I have a maximum? Nope. It is positive infinity, and I don't know where that's at. Okay, where are my zeros at? Zeros are where it crosses the x-axis. It crosses at 3 points, at -1, 0, 1, 0, and 2, 0. So our zeros are -1, 1, and 2. Okay, what about our end behavior? Okay, as x goes to negative infinity, where does y go? It also goes to negative infinity. Okay, on the other end, as x goes to positive infinity, where does my output go? Positive infinity also. Okay, so now we're looking at relative local maximum or minimums. You could also see it called relative. Okay, relative or local minimum is where the graph goes from negative to positive. So if I am looking at this, this is where it goes from negative to positive in slope. That point is, I'm going to have to approximate is 1.5, and then negative, it looks like about 0.5, 0.5. For a local maximum, this is where it goes from a positive slope to a negative slope. Once again, I'm going to have to do a guesstimation. This is probably about -0.2. This is about 2.2. Remember, those are guesstimations. Okay, the last thing that I did not put on here, but I should have, what is my y-intercept? Where does it cross the y-axis? That is at 0, 2. So my y-intercept is simply 2. So as we looked at the key features of any graph, we have maximum, minimum, zeros. We look at what happens at both ends of the graph. We look for any local minimums or maximums, which are also the relative minimum or the relative maximum, and the y-intercept. So how do you know when you're successful? You know when you're successful when you can identify key features of a graph of a function. So these are key features of graphs.